Alright, so today we are discussing this topic polynomials for class 10th in mathematics, and I will be covering this topic using NCERT book. So I would recommend you to have the book beside you while attending this lecture. This lecture will be comprising of uh, these five parts. The lesson 1 will be about the introduction, that what all are we gonna do in these following exercises that are given in your NCERT book. And the lesson 2 to lesson 5 will be about exercises 1, 2, 3, and 4. The first lesson that we will do, and the thing that we will learn in it, will be the degree of polynomials. So whenever I talk about polynomials, that might confuse us what exactly this means. A polynomial is a kind of combination of variables and coefficients, and they are kept together using the arithmetical operators like plus, minus, subtraction, addition, multiplication, or you can even say division. So when the variables and coefficients are clubbed together, they are known as polynomials. And the degree of polynomials means that there is some power attached to it. What exactly this means is that, for example, I'm having an equation. For example, if I'm having an equation like 4x plus 2, this is my equation. Then what I will see in it is that where is my variable? First of all, I will try to locate my variable. As you can see, the variable is this part. What exactly variable is? Variable is something whose value is not fixed. In an equation, when the value is not fixed for any entity, that entity is known as variable. That means that value of it can be varied by the user, by us. Alright, so this x is a variable. Now power attached, the power attached to this variable will give me the degree of this polynomial. It is as simple as that. So the trick over here is that if I get an equation like 2x square plus 3x plus 4, then there are two variables, two types of variables. One variable is this with the power of 2, power is 2, and here the variable, the power is just 1. So over here what we do is, to calculate the degree of this polynomial, we go for the maximum power of variable. And since there is just one variable present in this equation, therefore I will call it a single variable. As you already know, there can be more than one variables, like there can be the equations like 2x square plus 4y plus 6 equals to 0, but we are not talking about this over here. We are just concerned about the single variables. So the maximum power of the variable will give you the degree of that particular equation, or what you can call now as polynomial. Alright. So in the first exercise, what we will learn is to find out the zeros of the polynomials. Zeros of the polynomials. What exactly this means is that, for example, I'm having an equation. Let's take it like 4x plus 3 and this one. 4x plus 3. This is my polynomial. All right. Now, what this exactly means is, what will be the value of x? What will be the value of x such that value of whole polynomial is equal to 0. Alright, so what I'm trying to say is that this is the whole polynomial 4x plus 3. Now what will be the value of x? What value should I need to place instead of x such that this whole polynomial will be equal to 0? Now if I'm able to find the value of x over here, then that value will be known as 0 of this polynomial. It is as simple as that. So what I can do, that I can shift this 3 over there towards the right hand side, then the sign will change, then it will be minus 3, then the over here it is multiplication, then it will go there with the as a cross multiplication, it will become division obviously, so it will be minus 3 by 4. So this value that I am getting over here of x minus 3 by 4. Now if I place this value in this polynomial, see the polynomial is 4x plus 3, right? Now if I place this value that I just received, minus 3 by 4, instead of x, what will it become? Instead of x I will place minus 3 by 4, this is plus 3. Now if I solve it, this will be like minus will come out, you can say it like this, 4 into 3 by 4 plus 3, 4 will be cancelled, minus 3 plus 3 will be 0. So as you can see, the value of x that we obtained from here is the value which, when placed in a polynomial, in a variable of that polynomial, it will give you the result as 0. So this minus 3 by 4, minus 3 by 4 is known as 0 of this polynomial. Alright. Now one more thing I need to make you understand is that, like the example was 4x plus 3. Alright. So this is my variable. Alright. This is my coefficient of variable. This is my constant value. Alright. So when I calculated the 0 of the polynomial, then what happened, that I got the value of minus 3 by 4. Alright. As you can see, this is nothing but negative of the constant value divided by the coefficient of variable. Uh, Now this is a kind of, you can say, formula, if you want to call it that the 0 of polynomial of degree 1. We need to remember it that this equation or this polynomial is having a degree of 1, because the maximum power of x, a variable, is 1 over here, so it will go 1. So the 0 of polynomial of degree 1 will be equal to negative of the constant value whole divided by coefficient of the variable. This is how you will calculate the 0 of polynomial of degree 1. Alright. So now let's understand that what exactly this 0 of the polynomial is. Now you already know that if I'm having any polynomial and this is nothing but kind of equation, and equations can be easily plotted on graph. Now let's see, like for example, the equation is 4x plus 3 that we're using the last time. So 4x plus 3 is a polynomial, and I can say that this 4x plus 3 is equal to, say, y. Alright. Now don't be confused at what this y is. What I'm trying to do here is trying to plot a graph. Now what a graph is exactly, that it is having the x coordinate and it is having a y coordinate. Alright. So what I'm trying to do is recreate these axes in this equation. So this x denotes the values present in the x-axis, and the y denotes the value that are present in the y-axis. It is as that simple. So what happens now is that we need to find some values in such a way that it is satisfied in this equation, or in other words, we need to plot this equation on this graph. It is very easy, right? So the method that we use is, we draw a table and we write like x and y over here. We need 3 points, then easily we can draw the line or whatever curve or whatever the pattern we get in the graph. So value of x, we need to place it first. So let's put the value of x as 0. If I place the value of x as 0 over here, then it is 4 times 0 plus 3, which will give me, this becomes 0, so it is 3. So y's value will be 3. It is 3. Now if I place the value as 1, like y equals to, sorry, like x equals to 1, and the value will be 4 times 1 plus 3. It will be 4 plus 3. So now when the value of x was 1, the value of y was 7. Now if I place the value of x as minus 1, then it will be 4 times minus 1 plus 3 plus 3. This will be like minus 4 plus 3, this will be minus 1. So when the value of x is minus 1, the value of y is also minus 1. Now we need to plot this. So when the value of x is 0, and the value of y is 3, so x is over here, the value of x is 0, so I will be over here, this point, y will be 3, so the 1, 2, 3 will go over here. This is my so-called first point. Now when the value of x is 1 over here, and the y is 7, that's too far, right? 1, 2, 3, 4, 5, 6, 7. It might come somewhere here. I'm not drawing it accurately, but it will give you the idea what I'm doing here. So when the value of x is minus 1 over here, the value of y is also minus 1. So this is a kind of line. See, this graph is not accurate, but when you will draw it in accurate way, this will give you the straight line. How do I know this is giving me a straight line? Because this is a equation with degree 1. Now all the equations that are having degree 1 are also known as linear equations. Linear equations. Now if any equation is having a degree of 2, then that is known as quadratic equation. Known as quadratic equation. Now if any polynomial is having degree of 3, it is known as cubic equation. So we should be clear with the terminology. So the linear equation exactly means that the line will be linear. That's why it's saying linear equations. So if you will plot any linear equation on a graph, then you will get a straight line. This is how it is getting. Now the point is, if I focus on finding the 0 of the polynomial, if I focus on trying to find the 0 of the polynomial using this graph, then what exactly that 0 means is the point where that graph is cutting the x-axis. Because x-axis, the value of y will always be 0. Alright, and this equation or polynomial is equal to y. And what I do to find out the 0, I say that 4x plus 3 is equal to 0. So I make that y equal to 0 indirectly. So what I need to find is where this polynomial as a graph or in a graph is cutting the x-axis. So when I can locate the point where this is cutting the x-axis, and that point is known as 0 of the polynomial. So the 0 of the polynomial, if I need to calculate it using direct equation, then I equate it equal to 0. Like the equation was 4x plus 3. If I needed to calculate the 0 of this equation, then I just said 4x plus 3 equals to 0. Then I calculated x as minus 3 by 4 and I got this as 0 of the polynomial. But if I need to calculate the 0 of the polynomial using the graph, then what I need to do is first plot it. I will get the plot. Then I will need to find that at what point the x-axis has been cut. This coordinate of the point where x-axis has been cutted will give me the 0 of the polynomial. This is all there is to understand about this 0 of the polynomial. So now let's jump to the exercise number 1, that is exercise 2.1. So this is the exercise number 2.1. So yeah, what this question is saying is the graph of x equals to px. Alright, don't be confused what this is. This is the polynomial, the way of writing the polynomial. For example, I just gave you that 4x plus 3. I can say it like px. I can even call it fx. These means functions. They're known as functions. So it is a way of representing the polynomials, you can say. It is just saying that it is having, this is a kind of polynomial, p represent the polynomial, which is having the variables of x. That's it. So don't be afraid of it. Now I said that I can write this like equals to y. So they are just writing it like y equals to px. Now we know they can do that. So this is what there is. So the graphs of y equals to px are given in figure this. This is that figure. Alright. For some polynomials px. I told you these are polynomials. Find the number of zeros for px. I need to find out how many zeros are present for the px. That means how many such values of x's are present, x are present, such that the polynomial's value will be equal to 0. I told you earlier that when I need to find it using the equation, I equate it with 0. I make it like 4x plus 3 equals to 0, then I find out the value of x. But when I need to find it using the graphs, then I need to find out that how many times that curve is cutting the x-axis. Alright. This is the x-axis, this is the y-axis. So I need to find out that the curve, how many times it is cutting the x. That's a simple thing that I need to do over here. So it is the find the number of zeros. Let's take the first graph. Alright. This is the graph, and this line represent any px, any polynomial. I'm not sure what the polynomial is over here, but I am not concerned for that in this question. I just need to find out that how many times this is cutting the x-axis. As you can see, it is not at all cutting the x-axis. It is very parallel to the x-axis. It will never ever cut the x-axis. So I can say that over here there is no intersection with x-axis, so there are 0 number of zeros. There is no value of x present that can make this polynomial equal to 0. That's it. First question will be like this. The second question is like this. This is the graph. This is my px graph. Alright. See, this is cutting y-axis, but I'm not concerned about y-axis. This is cutting x-axis one time. So the answer will be 1. Over here it is cutting 1, 2 and 3. This is y-axis. I'm not concerned about this. So 1, 2, 3. Answer will be 3. Over here, the axis has been cut by 1 and 2 times. Answer will be 2. Over here, 1, 2, 3, 4. Answer will be 4. Alright. Over here, 1, 2, 3. You might say that this is not cutting. No, even a touching part, I need to consider it as a cut. So 1, 2, 3. Answer will be 3. So this is how you calculate the number of zeros for the graph part. Alright. And if the equation has been given, you know the drill. You just need to make it equate to 0 and then you can find the value out of it. Alright. Thank you very much. This was exercise number 2.1. We will meet for exercise number 2.2 tomorrow. Thank you.